Welcome, everyone. You know that feeling when you step outside on a crisp, clear night, look up, and you're just totally mesmerized by the moon? For millennia, we've all been captivated by our nearest celestial neighbor. But every now and then, that familiar bright white orb does something completely extraordinary. It dims, it hides, and sometimes it actually transforms into this breathtaking, fiery copper color. Today, we're going to decode this beautiful celestial event. In this explainer, we're breaking down the exact mechanics behind this cosmic magic trick. We are setting out on a majestic journey, right from the surface of our planet straight into the vast, gorgeous backdrop of space.
Okay, let's dive right into this. What exactly happens when Earth's shadow falls on the moon out there in space? I mean, it sounds simple enough, right? We deal with shadows down here every single day. You walk out into the sun, your body blocks the light, boom, shadow on the ground. But what happens when a massive planetary body like the Earth casts its shadow across the sheer vacuum of space? And more importantly, what happens when the moon, just doing its orbital dance, wanders directly into that massive shadow? This isn't just a simple game of light and dark, it's this incredibly profound interaction of scale, distance, and absolute perfect timing.
So let's start with part 1, Celestial Miracle, the lunar eclipse.
To really grasp how this miracle happens, we've got to zoom out. Like way out. Space is unimaginably vast, and the actual distances between the sun, the Earth, and the moon are just staggering. Because the universe is so insanely huge, and because planetary orbits are usually tilted and kind of messy, these bodies don't just line up every day. When they actually do, it is a marvel of absolute clockwork precision. The whole phenomenon only begins when the sun, the Earth, and the moon align in a perfectly straight line. Just imagine an invisible string pulled super tight across the solar system. On one end, you've got the sun, just blasting out immense amounts of light. On the far end, you have the moon. And positioned right smack in the middle, perfectly interrupting that colossal stream of sunlight, is us, the Earth. Since the Earth is totally opaque, it acts like a giant cosmic shield, totally blocking the sunlight from continuing on its path.
Which brings us to part 2, the science of shadows. Specifically the umbra and the penumbra.
Now, what's really interesting here is that when Earth blocks the sun's light, it doesn't just create one single boring blob of darkness in space. Because the sun isn't just a tiny point of light, it's a massive blazing sphere. Its light actually hits the edges of the Earth from slightly different angles, and that fascinating geometry creates a highly specific layered shadow. So let's break down this shadow anatomy, starting right at the core, the umbra. The umbra is the main, darkest central shadow of the Earth. I want you to picture a deep, dark, tapering cone of absolute shadow extending millions of miles out in space. Literally, if you were floating in a spaceship right in the middle of the umbra and you looked back toward the sun, you wouldn't see it at all. The Earth would be completely blocking it. The umbra is the absolute absence of direct sunlight. It's the very heart of the eclipse.
But right outside that deep dark core is something completely different, the penumbra. In stark contrast to the umbra, the penumbra is the lighter outer shadow. It forms its wider, fainter cone that fans out all around that central darkness. In this zone, the Earth is really only partially blocking the sun. If your imaginary spaceship drifted out of the umbra and into the penumbra, you'd suddenly see a piece of the sun peeking out from behind the Earth. Because it's only a partial shadow, the penumbra is way lighter. And as we're about to see, it completely sets the stage for the different, highly specific visual effects we get to watch from our backyards down here on Earth.
All right, let's get to our main characters in part 3, the 3 main types of lunar eclipses.
So, we've got our perfect cosmic alignment, and we've got our 2 distinct shadow zones. As the moon orbits the Earth, its path can actually take it through different parts of these shadows, which gives us 3 totally distinct types of eclipses. Let's see how this builds, starting with the most subtle one of the bunch, the penumbral lunar eclipse. In this scenario, the moon's orbit carries it only through that lighter outer shadow, the penumbra. It completely misses the dark central core. Because the penumbra still lets some sunlight pass through, the effect on the moon is, well, it's very delicate. The moon doesn't disappear and it doesn't dramatically change color. Instead, it just looks a tiny bit faded or dim, kind of like someone just barely turned down a cosmic dimmer switch. It's a really beautiful, understated event. But what happens when the moon's journey takes it even deeper into the shadow? That's when we get a partial lunar eclipse. Here, the alignment is just a little bit tighter, and a fraction of the moon actually enters that deep, dark umbra. From our perspective on Earth, it literally looks as though a massive, curved bite has been taken right out of the glowing lunar surface. The part of the moon that's still in the penumbra stays relatively bright, while the specific piece that dips into the umbra looks blackened and completely obscured. It's an absolutely stunning visual contrast hanging right above us.
And finally, we build to the absolute climax of this celestial narrative, the total lunar eclipse. This happens when the alignment is absolutely flawless, and the entire moon gets swallowed up by the deep central umbra. But here is the most magical part. Instead of just completely vanishing into the darkness, the moon puts on a ridiculous show. It glows with this striking, fiery, reddish-copper hue. Now, why does it do that? Well, because the Earth's atmosphere actually acts like a giant lens in space. It filters out the blue light and bends the red light directly into the shadow. You are essentially seeing every single sunrise and sunset happening on Earth, all at the exact same time, projected right onto the surface of the moon. Mind-blowing, right? It is a profound, awe-inspiring sight that perfectly demonstrates the physics of our atmosphere on a massive cosmic scale.
And this brilliantly illustrates the whole progression, tying it all together. When the moon is positioned out in the penumbra, it simply looks faded. When it straddles the line and partially enters the umbra, we get that sharp, dark contrast of a partial eclipse. And when it is fully, totally submerged in the umbra, boom, we get the spectacular reddish-copper color of a total eclipse. It just directly connects the hidden mechanics of invisible space shadows to the beautiful colors and shapes we actually observe in the night sky.
So the crucial point here is that the universe isn't just some random assortment of bright lights in the dark. It is a highly structured, constantly moving mechanism of geometry, light, and shadow. By understanding the umbra and the penumbra, you aren't just looking at a pretty sky anymore. You're literally witnessing the massive, invisible mechanics of our solar system happening in real time. As we wrap up this explainer, I want to leave you with one quick question to think about. The next time you look up and see the moon glowing with that haunting reddish tint, which shadow will you be looking at? Armed with this knowledge, I guarantee your next stargazing session is going to be a whole new experience. Thank you so much for learning with us.